For decades, physicists have operated under a single assumption about the cosmos. A mysterious outward pressure called dark energy is stretching the fabric of space, and it acts as a permanent, unchanging constant. Because this force never fluctuates, we calculated exactly how reality ends. The universe expands forever, galaxies drift out of sight, and everything slowly cools into a frozen, permanent void. But new data is challenging that timeline. This 3D spatial plot shows the largest map of the universe ever made. Every single point you see here is a galaxy or a supermassive black hole, compiling exactly 47 million dots. Buried inside that massive dataset is an anomaly. The numbers simply do not align with the idea of a constant, unchanging force. To see why the predicted death of the universe has shifted, we actually have to look at the incredibly small, Earth-bound machines used to build this map. Instead of deep space, the data collection happened here on the ground, inside a terrestrial observatory. The heart of the operation relies on an array of 5,000 tiny automated robots, each rigged with a fiber optic cable. Their job is highly specific. The arms automatically pivot to target and lock on to celestial coordinates. By automating this targeting process, the observatory can collect light from 100,000 different galaxies in a single night. Taking those nightly observations and turning them into a cohesive map required 900 researchers working continuously over 5 years. Deploying thousands of synchronized robotic eyes was the only practical method for gathering enough data to measure an invisible force spanning the cosmos. Once the data is collected, astronomers must translate these physical light measurements into a working history of the universe. Because light takes time to travel, observing distant objects means seeing them as they existed billions of years in the past. Astronomers measure how matter was clustered back then and compare it to nearby galaxies to see how it's clustered today. By mapping the spatial distances, the researchers actually created a chronological timeline. They can track the exact behavior of dark energy across eons. With that timeline built, we can test the original assumption that dark energy never changes. This graph plots dark energy's strength over millions of years. If constant, the data forms a perfectly straight horizontal line from the past to the present. But approaching the modern day, the trend line physically dips. The expansion rate is fluctuating. The data indicates dark energy was stronger several billion years ago, and it is actively getting weaker right now. A weakening outward push means the universe is not locked into an eternal, steady expansion. The physical ending of reality could look vastly different than the slow, cold fade we originally calculated. It took 5,000 small robots staring through fiber optic cables to prove that the largest invisible force in nature is losing its grip on the cosmos.